The handling of the TCP connection can happen in two different ways: non-persistent and persistent. In a non-persistent HTTP connection, after the TCP connection is established between the client and the server, at most one object is sent on that connection, and then the connection is closed. Downloading multiple objects in this method needs multiple different connections. And if a single HTML page references multiple objects, each of those objects would need a different TCP connection for their transmission. In the persistent HTTP, after the TCP connection is established between the client and the server, many objects can be sent over that single TCP connection. Let's see an example of non-persistent HTTP in action. Let's assume the user wants to see www.sfu.ca/computing/index.html and therefore enters this URL at their browser. In the first step, HTTP client initiates TCP connection to HTTP server process at www.sfu.ca on port 80. An HTTP server at that host, which was waiting for TCP connection at port 80, accepts the TCP connection, notifying the client. Now the connection is established. An HTTP client sends HTTP request message containing the URL into TCP connection socket. At this stage, the message indicates that client wants the object indicated at that URL. The HTTP server receives the request message, makes the response message containing the requested object, and sends it into its socket. And then it closes the connection. An HTTP client receives the response message containing the HTML file and displays the HTML. Now, if the client finds referenced object in the HTML file while parsing it, for example, JPEG files for images, it has to go through all of the steps 1 to 5 for each of the objects. These steps include establishing and closing of the TCP connection for each of the objects. What are the implications of establishing and closing the TCP connection for each request? Let's take a look at the time it takes to respond to an HTTP request. The time for a small packet to travel from client to server and back is called round trip time, or RTT. When an HTTP request is sent from a client to the server, it takes one RTT to initiate TCP connection. Then it takes one RTT for the HTTP request and first few bytes of the HTTP response to return. And there is also the file transmission time. So, non-persistent HTTP response time is 2 RTT plus file transmission time. The problem is, for each object transmitted, there is a 2 RTT overhead time. Browsers can fetch the objects in parallel to reduce the effect of that overhead, but per object retrieval time is 2 RTT plus object file transmission time for each object in the non-persistent HTTP. To alleviate the non-persistent HTTP response time overhead problem, persistent HTTP could be used. In persistent HTTP, server leaves the connection open. The client sends the request as soon as it encounters a referenced object, and HTTP messages between same client and server can happen over the same open connection. This reduces the transmission time to as little as 1 RTT plus the file transmission times for all the referenced objects.